Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now going through question number 8 from the June 2022 International A-Level Pure Mathematics P4 exam from Edexcel. This question here, we're given these two figures. It says figure 2 shows the curve with the equation y equals 10x times e to the power of negative a half x, and x is between 0 and 10. It says the finite region R, shown shaded in figure 2, is bounded by the curve, the x-axis, and the line with the equation x equals 10. The region R is rotated through 2 pi radians about the x-axis to form a solid of revolution. Show that the volume V of this solid is given by this formula: V equals K times the integral of x squared times e to the power of negative x with respect to x between 0 and 10, where k is a constant to be found. So basically this shape is going to be rotated round the x-axis. Okay, so it's going to end up looking something like this, but three-dimensional. It's going to go all the way around this axis, so it'll end up being like a three-dimensional kind of shape. All right, so what we have to do when we've got a volume of revolution is we've got to basically imagine that you're going to have a series of cylinders. So I'll just draw it over here. You'll have a series of cylinders that are kind of like added together to give you the whole of this shape. Okay, so when you rotate it around, this is like the x-axis. You can say this is the x-axis. Okay, when you rotate this around, you're forming this little cylinder, and in this cylinder, the radius of the cylinder represents the y value of that particular point. Okay, so you have a cylinder that's really thin, okay, and the radius of the cylinder is like the y value, and the height of the cylinder, or the thickness of the cylinder, is like a small little part of the x-axis, very small part. We call it dx. So we know the volume of a cylinder is given by pi r squared h. Pi times the radius squared times how thick the cylinder is. So in this case, we're going to have the volume of this little tiny cylinder will be pi times y squared times dx. Now what we want to do is we want to find the volume of this whole of this shape. So we've got to think about all the cylinders that are formed from the beginning to the end of the shape, from 0 to 10. So we're talking about this, we're not talking about the whole of this, we're talking about half of this, which is this area over here when it's rotated around. So what we can do is we can basically, if we add together all those cylinders, we're going to find the sum of the cylinders, okay, from x equals 0 to x equals 10 of pi y squared dx, which is basically what we get when we integrate, okay, pi y squared dx between 0 and 10. Okay, so this will give you the volume of that particular shaded region when it is rotated around the x-axis by 1 revolution, which is 2 pi. Okay, so I like to write it as pi, because it's a constant, times y squared dx, and we got the limits from 0 to 10. So we know that y is the original formula, which is 10 times x e to the power of negative a half x. So we know y equals 10x times e to the power of negative a half x. So all we need to do now is just put that instead of the y. So we're going to have the integral between the limits of 0 and 10 of, you're going to have 10x times e to the power of negative a half x, and we're going to integrate that with respect to x. Okay, so sorry, that's going to be squared. That's going to be squared, and that has to be integrated with respect to x. So that's going to give us pi between 0 and 10. That's going to give you 100 x squared. If you square e to the power of minus a half x, you've got to basically multiply that by 2. That's going to give you e to the power of negative x dx, and that 100 is, we can write it outside, So you end up with v equals 100 pi times x squared e to the power of minus x dx. And that's exactly what we had to show. Some constant, okay, times integral between 0 and 10 of x squared e to the power of negative x dx. So we could say, if you want, k equals 100 pi. Okay, you don't have to write that, you just put it in this form. Okay, so we've got the answer for part A. Okay, now for part B, we are asked to integrate this expression with respect to x. It's kind of separate from part A, but kind of related, because this expression is part of what we had to show, and of course I think it's going to be used in part C. But the question, part B, just simply tells us to integrate this particular expression. Now here we have an integration that involves the product of two functions that are not related to each other. You can't use, for example, the reverse of the chain rule in this case. You don't have something multiplied by something which is of the form of the differential of what's inside the function or anything like that. So here we have to use what's called integration by parts, which is where you call one of the parts, one of the products, you call it u, and the other product you call it dv dx. So for the one that's called u, you have to differentiate it to get du dx. So that has to be differentiated, and the one that we call dv dx has to be integrated, and that will give us v. Okay, now how do you choose what's u in dv dx? Well, u is normally chosen as the one that breaks down, which is like the polynomial type, like x squared. X squared, when you differentiate, becomes simpler, right? But e to the power of negative x, when you differentiate, it doesn't really become simpler. It becomes negative e to the power of negative x. So it kind of comes, you know, equally as complicated or more complicated. So differentiating x squared would be sensible, and integrating e to the power of minus x would be sensible here. So u is x squared, dv dx is e to the power of negative x, du dx is going to become 2x, and dv dx, when you differentiate it, it's going to become v. When you integrate it, so it will become v, and that's e to the power of negative x divided by negative 1. You have to divide by the differential of what's inside the function. So e to the power of negative x integrates as e to the power of negative x. It doesn't change, but then you divide by the differential of what's inside the function, so you end up with negative e to the power of negative x. Now, when you are integrating something by parts, you have x squared e to the power of negative x dx. That's equal to, so what you do is you multiply these two together, so it's u times v first, which is going to give you x squared times minus e to the power of negative x, which is minus x squared e to the power of negative x. Then you subtract from that the integral of the product of these two. The integral of the product of these two. So you're going to have, this is going to be 2x times negative e to the power of negative x with respect to x. Now that's going to give us, well, we'll keep this as it is. That minus, if I take it like minus 2 out of this, if I take the 2 and the minus 1 outside, you're going to get a plus 2. Okay, because that minus taken out makes that plus. Taking the 2 out, just to make life easier, then you have x e to the power of negative x dx. Now this doesn't integrate again by itself. So what you have to do again is use integration by parts a second time. So again, I'm going to call u the polynomial one, which is x. I'm going to call dv dx, again, e to the power of negative x. So du dx is going to become 1, and v is going to be, again, negative e to the power of negative x. So I'm going to, again, use integration by parts. So I've got negative x squared e to the power of negative x plus 2 times, now I'll use integration by parts for this. So I'll multiply these together. I get negative x e to the power of negative x. Take away the integral of these two multiplied together. So you have minus e to the power of negative x. I'll take the minus 1 out, so I'll have plus e to the power of negative x with respect to x. And now I can finish this off. This is minus x squared e to the power of negative x plus 2 times negative x e to the power of negative x, and this is going to give you negative e to the power of negative x. Why? Because integrating this stays the same. Then you divide by negative 1, the differential was inside the function. Now I'm going to put plus c, as it's an indefinite integral, this particular part of the question. There's no limits, so I'm going to put the plus c. So now, if we just simplify that, you've got minus x squared e to the power of negative x. You've got minus 2x e to the power of negative x and you got minus 2 e to the power of negative x plus c. So there's the answer to the question, which is question number 8 part B. Okay, there's answer to 8 part B. Yeah, so that's negative, that's right. Okay, so now I'm going to go on to question part C. Now part C says figure 3 represents an exercise weight formed by joining two of these solids together. Okay, so you got one of the solids, which, you know, the volume of revolution that we found, the expression for it was this, with 100 pi, okay, as K. It says the exercise weight has a mass of 5 kilograms and is 20 centimeters long. Now that means that basically, you know, one of those units was 1 centimeters. Okay, so you know, when we did from 0 to 10, that's 10 centimeters long. So it works out that this whole thing is 20 centimeters. So that will help us. Okay, given that density is mass over volume, using your answer to part A and part B, find the density of this exercise weight, giving your answer in grams per centimeters cubed to 3 significant figures. Okay, so we know that the volume of the whole shape is going to be 2 times 100 pi times the integral of 0 to 10 of x squared e to the power of negative x dx. That's going to be the volume of the whole thing, because you got two of them stuck together. Okay, so you can say that the volume of the whole thing is going to be 200 pi times the integral between 0 and 10 of x squared e to the power of negative x with respect to x. Now this is we already found. We found the answer to this. So the volume of the whole thing is going to be 200 times, I'm going to put down what we got as the integral of this. Okay, so this is what we got for the integral. We got minus x squared e to the power of minus x minus 2x e to the power of negative x minus 2 e to the power of negative x, and it was a common factor between 0 and 10. Okay, so what I can also do here is I can, making it a bit easier, I can say 200 pi, and then I can have something like this, e to the power of negative x and minus x minus 2x and minus 2. Okay, that will do. I'll have to keep putting that in all the time. So now that will give me v equals 200 pi times, now this will be e to the power of negative 10 times minus 10 minus 2 times 10, which is minus 20, minus 2. This is x squared, sorry. Minus 10 squared. Now that, sorry, that's the x, negative x squared. I forgot to write that. So that's negative 10x squared. Now that doesn't mean negative 10 squared. It means negative 10 squared, where the minus is not part, as you can see, it's not part of the square. So this is minus 10 squared. So the 10 is squared and it still remains a minus. It's not negative 10 all squared. You have to be careful about that. And then I've also got to substitute 0 into this. Okay, so I've got to take away, and I'll have e to the power of 0. Now 0 into here will give me 0, and into there will give me 0, so I'll be left with negative 2 there. So now I've substituted the values in, so I can say that the volume of the whole thing is 200 pi times, this is going to give you minus 100, so it's going to be minus 122 e to the power of negative 10. Remember, this negative is not inside. It's not like minus x all squared. It's minus x squared. Okay, so the 10 is squared and it's a negative 10 squared. Okay, so you got negative 122. That's negative 100 minus 120 minus 122. And this is going to give you plus 2, because you're going to have, this is 1 times minus 1 times minus 2, which is plus 2. So that's the volume of the whole shape. Okay, I'm going to leave it in this exact form and then round my final answer in the end. It says density equals mass over volume, and we're going to find the density in grams per centimeters cubed. So we know that density equals mass over volume. The mass is 5 kilograms, which is 5,000 grams. We've got to have it in grams per centimeters cubed. So we end up with, we got 5,000 divided by this answer, which I'll keep in this exact form, minus 122 e to the power negative 10 plus 2. And remember, this is in centimeters cubed because we said that they told us that this is 20 centimeters. So these 10 units and, being doubled is, altogether in centimeters cubed now. Okay, so you got 5,000 over this answer. So we got the answer that, let's just put, we got 5,000 divided by, and I'll just put this 200 pi times minus 122 e to the power of minus 10 and plus 2. Okay, plus 2, close that bracket. Now that's going to give us the density in grams per centimeters cubed, which is 3.9899. Okay, that's 3.9899. Okay, 9899. So to 3SF, that's 3.99 grams per centimeters cubed. Okay, that's the density of this object. Okay, so there's the answer to that. Now, if we wanted to check our answer is correct, okay, if we want to check our answer is correct, what we can do is we can take our 5,000. Okay, so let's just save this answer under A. Okay, now, if I take 5,000 and divide it by 200 pi times 200 pi times the integral of what we've got here, which is x squared. So I'll put x squared times e to the power of negative x within the limits of 0 and 10. Now that should give us the same answer, 3.9899. So we press equals. It gives us exactly the same answer. Okay, so we know that we haven't made a mistake. So this will confirm to us that we integrated part B correctly, and it will confirm to us that we did the right thing for part C also. Okay, so using your calculator, obviously, just to write the answer down, you won't get any marks, as it mentions in the beginning of the question. All right. However, using your calculator to do a quick check like this to make sure that you haven't made any silly mistakes, now that's fine, of course, because you've shown all your steps. So you've shown the exam, you know what to do. What you're doing here now is just checking for yourself that you haven't done anything silly. Like you could have done something silly, like for example, in the beginning, and when I was writing this down, I think I didn't write minus 10 squared. I wrote minus 10. Then I realized, and I corrected it. So if I hadn't realized, I would have seen my answer isn't correct. And then I could check to see, okay, hold on, where did I make my mistake? So that's why it's a very good idea, especially if you have time, to always check your answers using your calculator to make sure that you haven't made any silly mistakes and that you're on the right tracks. Okay, and again, part A, part B, part C, they're kind of like, separate in the sense that if you didn't know how to do part A, you can still do part B if you know how to do integration by parts. And if you didn't know how to do part A, part C, you might get some marks for it without having the 100 pi there or the 200 pi there. You might get some marks for it by just, knowing and understanding that density equals mass over volume, and, using the expression for the volume, okay, of one of those items. You could have then got some of the marks. It's worth 5 marks. You would have salvaged some of the marks by, just substituting those values if you knew how to integrate part B, for example. So there's lots of different things that you have to take into account when you're doing these questions. Don't ever look at part A, say, I don't know how to do part A, therefore I can't do part B. Especially the newer questions now, they're making the different parts accessible to students who couldn't do part A, that there's enough information given for you to do part B, if you have the understanding of that particular part of the topic. All right, so it's very important for you not to give up when you can't do one part of a question. Always check to see if you can do the others and salvage, sometimes most of the marks for the question. All right, so that concludes question number 8 from this P4 International A-Level June 2022 paper. Other questions from this particular paper can be found in the playlist that will appear in this region. Other questions from integration of P4 can be found in the playlist over here. I'll also have a playlist specifically to do with substitution, and another one specifically to do with volumes of revolution. I'll put this into both of those as well. Thank you for watching and see you soon.